Top 25 Bridge Engineer Interview Questions and Answers. Top 25 Questions for Success. Bridge engineers play a vital role in designing, analyzing, constructing, and maintaining bridges that ensure safe transportation for communities. Employers look for candidates with strong technical knowledge, problem-solving abilities, project management skills, and a commitment to safety standards. During a bridge engineer interview, you may be asked about structural design principles, construction materials, inspection procedures, load calculations, and real-world project experiences. Preparing for these questions can significantly improve your confidence and performance. The following guide covers 25 commonly asked bridge engineer interview questions and detailed answers to help you succeed. 1. What are the primary responsibilities of a bridge engineer? A bridge engineer is responsible for planning, designing, analyzing, inspecting, and maintaining bridges. Their duties include performing structural calculations, selecting suitable construction materials, ensuring compliance with safety regulations, and overseeing construction activities. They collaborate with architects, contractors, and government agencies to complete projects successfully. Bridge engineers also conduct inspections and evaluate existing structures to identify maintenance needs. Their ultimate goal is to create durable, safe, cost-effective bridges that can withstand environmental conditions and expected traffic loads throughout their service life. 2. What factors do you consider when designing a bridge? When designing a bridge, I consider traffic volume, load requirements, environmental conditions, soil characteristics, construction costs, maintenance needs, and safety regulations. I evaluate potential hazards such as earthquakes, floods, strong winds, and temperature changes. Material selection is also important to ensure durability and cost efficiency. Additionally, I analyze the bridge's lifespan, future expansion possibilities, and environmental impact. By considering these factors, I can develop a design that balances structural integrity, functionality, sustainability, and economic feasibility while meeting project objectives and engineering standards. 3. What types of bridges are commonly used? Common bridge types include beam bridges, arch bridges, truss bridges, suspension bridges, cable-stayed bridges, and cantilever bridges. Beam bridges are simple and economical for short spans. Arch bridges efficiently transfer loads through compression. Truss bridges provide strength through interconnected triangular components. Suspension bridges are suitable for very long spans and use cables for support. Cable-stayed bridges combine aesthetics with structural efficiency. Cantilever bridges are useful when support from below is difficult. The choice depends on span length, site conditions, budget, and project requirements. 4. How do you calculate bridge loads? Bridge load calculations involve determining dead loads, live loads, environmental loads, and dynamic forces. Dead loads include the bridge's self-weight and permanent components. Live loads consist of vehicles, pedestrians, and traffic movement. Environmental loads include wind, seismic activity, temperature changes, and water forces. Engineers use established design codes and structural analysis software to calculate these loads accurately. Proper load calculations ensure the bridge can safely withstand expected stresses and maintain structural stability throughout its service life without excessive deflection or failure. 5. What is the importance of structural analysis in bridge engineering? Structural analysis helps engineers understand how a bridge responds to various loads and forces. It identifies stress distribution, deflection, vibration, and potential failure points within the structure. Through structural analysis, engineers can optimize designs, improve safety, and reduce material costs. Modern software tools allow engineers to simulate real-world conditions and predict bridge behavior accurately. This process ensures compliance with engineering standards and helps prevent structural issues during construction and operation. Effective structural analysis is essential for creating reliable, durable, and safe bridge structures. 6. How do you ensure bridge safety during design? Bridge safety begins with adherence to engineering codes, standards, and regulations. I perform detailed structural analyses, verify load calculations, and evaluate environmental risks. Material selection focuses on durability and performance under expected conditions. Safety factors are incorporated into designs to account for uncertainties. Peer reviews and quality control procedures help identify potential issues before construction. I also consider inspection accessibility and future maintenance requirements. By integrating these practices, I ensure the bridge can safely support intended loads and withstand environmental challenges throughout its lifespan. 7. What bridge design software are you familiar with? I am familiar with bridge engineering software such as AutoCAD, Civil 3D, SAP 2000, STAAD.Pro, Midas Civil, and CSI Bridge. These programs assist with structural modeling, load analysis, design verification, and project documentation. AutoCAD and Civil 3D are useful for drafting and design layouts, while SAP 2000 and SDA.Pro support advanced structural analysis. Midas Civil and CSI Bridge offer specialized tools for bridge engineering projects. Proficiency in these software applications improves accuracy, efficiency, and collaboration throughout the bridge design and construction process. 8. How do you handle challenging site conditions? Challenging site conditions require thorough investigation and planning. I begin by conducting detailed geotechnical and environmental assessments. Understanding soil properties, groundwater levels, terrain constraints, and environmental risks helps determine suitable design solutions. I collaborate with specialists to evaluate alternatives and select the most practical approach. Construction methods may need adjustment to address accessibility or safety concerns. Continuous monitoring during construction ensures potential issues are identified early. Effective planning and teamwork allow bridge projects to succeed even in complex and demanding site conditions. 9. What materials are commonly used in bridge construction? Bridge construction commonly uses concrete, steel, pre-stressed concrete, timber, and composite materials. Concrete offers durability and compressive strength, making it suitable for many bridge components. Steel provides excellent tensile strength and flexibility for long-span structures. Pre-stressed concrete enhances load-carrying capacity and reduces cracking. Timber is occasionally used for smaller bridges in specific environments. Composite materials combine the advantages of different materials to improve performance. Material selection depends on project requirements, environmental conditions, maintenance expectations, and budget considerations while ensuring structural reliability and longevity. 10. What is fatigue in bridge structures? Fatigue is the gradual weakening of structural components caused by repeated loading and unloading cycles. Over time, these stress cycles can create small cracks that grow and potentially lead to failure if not addressed. Fatigue is especially important in steel bridges exposed to constant traffic loads. Engineers minimize fatigue risks through proper design, material selection, inspection programs, and maintenance activities. Understanding fatigue behavior helps ensure bridge safety and longevity. Regular monitoring allows engineers to identify and repair fatigue-related damage before it becomes critical. 11. How do you inspect an existing bridge? Bridge inspections involve visual examinations, measurements, and testing to assess structural condition. I evaluate components such as decks, beams, piers, bearings, joints, and foundations for signs of deterioration, cracking, corrosion, or deformation. Inspection reports document findings and recommend maintenance actions. Advanced techniques such as drones, sensors, and non-destructive testing may be used for detailed assessments. Regular inspections help identify issues early, reduce repair costs, and ensure public safety. A systematic inspection process supports effective bridge management and extends the structure's service life. 12. What is the purpose of bridge bearings? Bridge bearings transfer loads from the bridge superstructure to the substructure while allowing controlled movement caused by temperature changes, traffic loads, and structural deformation. They reduce stress concentrations and prevent damage resulting from expansion and contraction. Bearings can accommodate rotation and horizontal displacement, helping maintain structural integrity. Different bearing types are selected based on bridge design and movement requirements. Proper bearing installation and maintenance are essential for long-term bridge performance. Faulty bearings can lead to excessive stresses and costly structural problems if neglected. 13. How do environmental factors affect bridge design? Environmental factors significantly influence bridge performance and durability. Engineers must account for wind loads, temperature variations, floods, earthquakes, corrosion, and soil conditions. Coastal environments may accelerate corrosion due to salt exposure, while seismic regions require earthquake-resistant designs. Temperature changes cause expansion and contraction that must be accommodated through joints and bearings. Hydrological studies help determine flood risks and foundation requirements. Considering environmental factors during design ensures the bridge remains safe, functional, and durable under varying conditions throughout its intended lifespan. 14. What are expansion joints and why are they important? Expansion joints allow bridges to expand and contract due to temperature fluctuations and structural movements. Without expansion joints, thermal stresses could cause cracking, distortion, or other structural damage. These joints help maintain bridge integrity by accommodating movement while providing a smooth surface for vehicles. Proper design and maintenance of expansion joints are essential because damaged joints can allow water infiltration, leading to corrosion and deterioration. Expansion joints contribute significantly to the bridge's durability, safety, and long-term performance under changing environmental conditions. 15. How do you prioritize bridge maintenance activities? I prioritize maintenance activities based on safety risks, structural condition, traffic importance, and available resources. Inspection data helps identify critical defects requiring immediate attention. Structural components showing severe deterioration, corrosion, or damage receive the highest priority. I also consider the bridge's strategic importance and potential impact on public transportation. Preventative maintenance is emphasized to reduce long-term costs and extend service life. By using a risk-based approach, maintenance resources can be allocated efficiently while ensuring public safety and preserving infrastructure reliability. 16. What steps do you take to control project costs? Cost control begins with accurate planning, budgeting, and resource management. I develop detailed estimates, evaluate alternative designs, and select cost-effective materials without compromising safety or quality. Regular monitoring of project progress helps identify potential cost overruns early. Effective communication with stakeholders and contractors minimizes delays and misunderstandings. I also implement value engineering techniques to improve efficiency and reduce unnecessary expenses. Maintaining strong project management practices ensures financial objectives are met while delivering a bridge that satisfies technical and operational requirements. 17. How do you manage construction risks? Construction risk management involves identifying hazards, assessing potential impacts, and implementing mitigation strategies. I review project plans, site conditions, and construction methods to identify risks related to safety, scheduling, environmental issues, and structural performance. Safety protocols, contingency plans, and regular inspections help minimize potential problems. Effective communication among project teams ensures everyone understands risk management procedures. Continuous monitoring throughout construction allows timely corrective actions when needed. A proactive approach to risk management improves project outcomes and protects workers, the public, and infrastructure investments. 18. What is load rating in bridge engineering? Load rating is the process of evaluating a bridge's capacity to safely carry specific loads. Engineers analyze structural components, material properties, and current conditions to determine allowable load limits. Load ratings help identify whether weight restrictions are necessary and guide maintenance or rehabilitation decisions. The process considers deterioration, design standards, and inspection findings. Accurate load ratings are essential for ensuring public safety and preventing overloading. They also support infrastructure management by helping agencies prioritize repairs, upgrades, and replacement projects effectively. 19. How do you approach bridge rehabilitation projects? Bridge rehabilitation begins with a comprehensive condition assessment to identify deficiencies and performance limitations. I evaluate structural components, load capacity, and deterioration mechanisms before developing rehabilitation strategies. Solutions may include strengthening members, repairing concrete, replacing bearings, or upgrading protective systems. Cost, safety, traffic disruption, and long-term performance are carefully considered. Collaboration with stakeholders ensures project objectives are met. Rehabilitation extends bridge service life, improves safety, and enhances functionality, while often providing a more economical alternative to complete replacement. 20. How do you ensure quality during construction? Quality assurance involves establishing standards, conducting inspections, reviewing materials, and monitoring construction activities. I verify that work complies with project specifications, engineering drawings, and regulatory requirements. Testing of materials such as concrete and steel helps confirm performance expectations. Regular site visits and documentation ensure quality issues are identified and corrected promptly. Effective communication with contractors and quality control teams supports consistent workmanship. Maintaining rigorous quality procedures reduces defects, improves safety, and ensures the completed bridge meets design objectives and performance standards. 21. What role does geotechnical engineering play in bridge projects? Geotechnical engineering is critical for evaluating soil and foundation conditions. It helps determine bearing capacity, settlement potential, groundwater influences, and foundation design requirements. Accurate geotechnical investigations reduce construction risks and improve structural performance. Engineers use this information to select suitable foundation systems, such as piles, caissons, or spread footings. Understanding subsurface conditions ensures the bridge can safely transfer loads to the ground. Geotechnical analysis supports stability, durability, and long-term reliability while minimizing costly foundation-related issues during construction and operation. 22. How do you address corrosion in bridges? Corrosion control begins with selecting durable materials and protective coatings. Regular inspections help identify corrosion early before significant damage occurs. Maintenance strategies include cleaning, repainting, replacing deteriorated components, and improving drainage systems. In aggressive environments, corrosion-resistant materials and cathodic protection systems may be used. Effective corrosion management extends bridge lifespan and reduces repair costs. By implementing preventative measures and monitoring structural conditions, engineers can preserve bridge integrity and ensure continued safety and performance under challenging environmental conditions. 23. Describe a successful bridge project you worked on. In a successful bridge project, I participated in design coordination, structural analysis, and construction support. My responsibilities included reviewing calculations, optimizing design elements, and resolving technical challenges during construction. Close collaboration with contractors and stakeholders helped maintain project schedules and quality standards. Regular site visits ensured compliance with design specifications. The project was completed safely, on time, and within budget while meeting performance requirements. This experience strengthened my technical expertise, communication skills, and ability to solve complex engineering problems effectively. 24. How do you stay updated with bridge engineering developments? I stay updated by participating in professional organizations, attending industry conferences, completing training programs, and reviewing technical publications. Engineering journals, research papers, and updated design codes provide valuable insights into emerging technologies and best practices. I also engage with professional networks and online engineering communities to exchange knowledge and experiences. Continuous learning helps me remain informed about advancements in materials, structural analysis methods, construction techniques, and safety standards. Staying current improves my ability to deliver innovative and effective engineering solutions. 25. Why should we hire you as a bridge engineer? You should hire me because I combine strong technical knowledge with practical problem-solving skills and a commitment to safety and quality. I have experience in bridge design, structural analysis, inspections, and project coordination. I work effectively with multidisciplinary teams and communicate clearly with stakeholders. My attention to detail helps ensure compliance with engineering standards and project requirements. I am dedicated to continuous learning and professional growth. Most importantly, I focus on delivering reliable, cost-effective, and sustainable bridge solutions that meet organizational goals. Preparing for a bridge engineer interview requires a strong understanding of structural engineering principles, construction practices, safety standards, and project management techniques. Employers seek candidates who can design safe and durable bridges while effectively managing challenges throughout a project's lifecycle. By studying these 25 bridge engineer interview questions and answers, you can improve your technical knowledge, strengthen your communication skills, and increase your confidence during interviews. Consistent preparation and real-world examples from your experience will help you stand out and demonstrate your value as a qualified bridge engineering professional.